Hey, buddy. I mean, thinking about you dreading doing the main road ahead, and you don't really know where to start with it. So I thought I'd do a short video for you because I've been thinking about this myself, and to the untrained eye, it looks like a really complicated, complex collection of bits. But this is taken directly out of the Augusta Westland maintenance folder. Okay, and the nuts and crux of this is you got one, two, three, four main assemblies that you need to do to build a hub. Okay, and the hub is made up of the bottom plate here, which I would say that's the place to start. Okay, because it's a flat plate. You can see these webs here. It's all flat, more or less with cylinders on the end of it in a five-pointed star. Okay, obviously I can send you the exact measurements, but that would be the best way to start it. The upper plate of the hub is the same layout in plan, except it's recessed here. It's more three-dimensional, whereas this is a flat plane. And then just underneath that separates the two is, for want of a better term for it, is basically a cone that's had the top cut off. It's a tapering cone. I don't know if you can see this correctly. And then on top, you've got the reservoir mount for all the lubrication. The drag links, which allows the blades or the sleeves and the blades to move horizontally back and forward, which is what you just seen in the previous film. These are the drag hinges here, and they basically fit on top of each other. And okay, they got all this gubbins there, but if you could start by just doing the top and bottom plate, the truncated cone, and the mount for the hydraulic reservoir on the top, that would be a really good start. And the only other bit you need to worry about then is the sleeves, which are more or less all the same. You know, for sleeves 3 and 4 are the ones that are at an angle. So from your point of view, it would be the same information in the computer, but basically you rotate it through, I think it's 20 degrees. But it is basically the same thing. They're all hinged apart from blade number 1, which is fixed. But the components themselves that make them up are exactly the same thing. Blade number 1, if I go outside, I can show you. Blade number 1 has got these massive bolts going through them, and it doesn't have the gearing inside. Otherwise, it would be one of these. If I close this one, that massive bolt is going through there and there's gearing. That's the only difference between the two. So you've got 4 out of 5 sleeves are exactly the same. This is the drag hinge there. Okay, and that allows... Now, I don't know if I can still move these. Yeah, you can see that the whole sleeve rotates on the drag hinge. Okay, this is slightly different on mine now because I'm starting to set it up for a manual fold and spreading. Okay, so you can see some non-standard bolts all over the place. That bolt there is stopping the head rotating out of MPOG, or minimum pitch on ground, MPOG they call it. So that's the base plate. Okay, and I would say it is about 8 or 9 millimeters thick. I don't know how detailed you want to make the inside. I mean, what's missing here and here are the mounts for the damper, and you can see one of the dampers that's still on this head. Okay, that's a truncated cone, which actually isn't a cone now I'm looking at it. It's more of just a cylinder with flared base and top. And then the top plate, this will be, of the two, that'll be the most complex to map for 3D printing. So let me know what you want. You know, if you want it, I can start doing the measurement from the center of the hub, or of the bottom plate, out to the end of the drag hinges. Okay, the drag hinges themselves, it's not very scientific, but they are that far apart, which I would say is about 13 or 14 centimeters. Okay, and if you look at the sleeve, this part of the sleeve is exactly the same for all of them. And if you were only to produce one and you left gear in it for blade number 1, I'm sure nobody's going to complain, because at whatever scale you do it, you know, that in 48 scale is going to be, that this gap here in 48 scale or 32nd scale isn't going to be very big anyway. It's probably going to be about 2 mil wide. So nobody's going to really complain about it. Well, we spoke before about how I think it should be done. I personally think you should do one rotor head and have the option for spread or folded blades. So you can do the sleeves either folded or spread, and you just put on whichever one you want on the main rotor head. You just decide which you want to do, and then sling them on. So you can either have them with all the teeth showing, with all this business showing, or you can have them fully closed. Okay, that's my take on it. I'm not going to do any measurements for you yet, until I know this is how you want to go about it. But my opinion is that if you do the hub assembly first, start off with the base plate and the upper plate or top plate, and that bit in the middle, and it should be quite an easy thing to do. It just looks complex. Okay, on this head here, I've only got one damper out of 5. For my purposes, you know, it's ideal. As you can see, I've got a hinge section, a threaded section there where I should have another damper. Okay, but for me, I am extending all the dampers to the fullest, because I want to prepare this for a main blade fold, and I don't need any movement. I don't want any movement there anyway. So as you can see, sleeves 1, 3 and 5 are already in position. I've just got the other 2 to do now. These are the ones that fold alongside the fuselage. Let me know what you want, buddy.